Afternoon everyone. So we'll be looking at this question called factory machines. The question says that you have n machines and you want to make tea products. You want to make tea products, right? And each machine has some specific time that it takes to make a product. So you will be given those n timings for those n machines. Uh, like I'll just give you a test case, and before that I'll tell you the limits. So the number of machines is limited by this number 2 into 10 power 5, and also the number of products that you're supposed to make is from 1 to 10 power 9, and the time that each machine would take is somewhere like this, right? This is the boundary set. So now let's take a test case. Let's say you're given 37325, right? Okay, so tell me that in 1 second how many machines can you make? Answer is 0, right? Like how many products you can make? Answer is 0. In 2 seconds if I ask, so this only one, right? One you can make. In 3 if I ask, okay. One thing is that you can operate all these machines simultaneously, right? Like when this one is working, this one can also work, and also this one can work, right? So the point is, in 3 seconds, see, this both will be completed, so I can make actually two products. In 4 seconds I can make two from here and one from here, so three products. And in 5 seconds I can make one from here, two from here, and one from here. So basically, how much? Four products. So now tell me one thing, that in t seconds, if I ask you in t seconds how many can I make in these three numbers, 3, 2 and 5 seconds for each of these machines, right? So then it takes, you can maybe understand, that is t by 3 plus t by 2 plus t by 5. This is the total, right? These many products you can make, right? So now tell me one thing, that what is the maximum time that is required? Like the question asks you to calculate the minimum time that you need to make these tea products. So I'm telling you what is the maximum time that will require. Now let's assume that each of these machines takes 10 power 9 seconds, right? This could be the case, that each of these n machines, and n is limited by this 2 into 10 power 5. So let's say each of these machines is taking 10 power 9 seconds, right? And you need to make 10 power 9 products. You need to make 10 power 9 products, right? So then how many will you require? Like how much time will you require? So like these n products will be done in 10 power 9 time, right? These n products will be done in 10 power 9 time. So the maximum we are setting as 10 power 9 square, because it's a n square loop, so we're setting it as 10 power 18. So now tell me one thing, that for each of these t, like from 1 to 10 power 18, right? So for each of my timings, if I can find that how many machines I'm making, so can I know that where to stop? Now tell me one thing, that let's say for like t time, right? If I'm able to make the number of products required, let's call that q. So let's say I require q products, and in t time I'm able to make these q products. So in t plus 1 time, can I definitely make q products? It has to be greater than equal to q, right? In t plus 2 time, it has to be greater than equal to q. And if I cannot make it in t minus 1 time, let's say I cannot make q products, let's say I'm making q minus 1 products in t minus 1 time, so that means that I cannot make q products in any time less than this, right? So can you see that, like this q thing, like this is true, like this q products making this thing is true after a particular point. So like this function, like if I call you that can I make these many products or not, so this function if I make, okay, this is going to be a predicate function, because it is going to return true after these and it is false before this, right? So it's simply predicate function. So you just need to find this bound, like this particular point, that whatever it is. So then what you will do, you will run a binary search. So you will set your low, at 1, and you will set your high at 118, right? So this is your low and this is your high. So, and what you will do, you will run a binary search, and for each of them what you will do is you will compute that how many you are able to make, how many products you're able to make. So you'll basically run a O of n loop, that for int I equal to 0, I less than n, I plus plus, and what you will do is you will add, like to products you will add products plus equal to, you will add for each. So basically if it is in some array a, so you can just divide by a of I, right? So if you just divide, then you will get that in that particular time, so in t upon if whatever time this is, right? Like you will take your mid, you will take some mid, so mid will be low plus I by 2, right? And then you will do like mid upon a of I for each of these, and then you will get that how many products you are able to make, right? Now if the products that you are able to make, if that is greater than whatever is required, let's say what is required is q, so if the number of products you are able to make, if that is greater than equal to q, so that means you need to set, like you will take an answer variable and you will store it in minimum of this particular answer that you have found, like whatever answer you can set to some 1e9 before, so it will be answer comma this particular count that I found, like the mid that I found, right? And I'll also set my high equal to mid minus 1, just to check that if in lesser time also can I do it, right? And the else part will simply do low equal to mid plus 1, because if in mid I'm not able to make, that means definitely I need to go to mid plus 1 at least to check whether I can make it or not. Thank you.